Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximize, minimize, and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Welcome back to part 2 of the Microsoft Azure Virtual Training Day, Implement a Lakehouse with Microsoft Fabric event. In this part, we will cover the last 3 sessions, starting with session 4, where we'll work with Delta Lake tables in Microsoft Fabric. In session 5, we'll ingest data with Dataflow Gen 2 in Microsoft Fabric. And finally, we'll wrap up part 2 and the event with session 6, where we'll discuss Data Factory pipelines in Microsoft Fabric. In this session, we will focus on introducing you to the Delta Lake and Delta tables and how to create and manage Delta tables using Spark. Delta tables are based on Linux's Data Lake table format, commonly used in Apache Spark, which is an open source storage layer for Spark, with relational database capabilities for both batch and streaming data. It gives us SQL-based data manipulation capabilities in Spark to support transactions and schema enforcement, coupled with the flexibility of data storage in a data lake. We will also see how to optimize Delta tables and how to use them in Spark structured streaming. Let's get started with session 4. Data Lake adds relational database semantics to Spark-based Delta Lake processing. Tables in Fabric Lakehouse are Delta Lake tables, which is signified here by the triangle or delta icon on the table in the Lakehouse Explorer, with the sales order table with a triangle on it. Specifically, Delta Lake tables are schema abstractions over the Delta files that are stored in Delta format. For each table, the Lakehouse stores a folder containing Parquet Delta files and a Delta log, as shown here, where the transaction details are logged in the JSON format. With Delta Lake tables from Apache Spark, our Delta Lake tables support ACID transactions like relational databases. They're designed to support transactional data modification. The ACID acronym has been around for over 30 years and highlights fundamental database principles intended to help guarantee data consistency and integrity for transactional databases. The A in ACID stands for atomicity. Transactions complete as a single unit of work or fail as a single unit of work. The C in ACID stands for consistency. Transactions leave the database in a consistent state. The I in ACID stands for isolation. In-process transactions are isolated from one another and can't interfere with one another. Lastly, the D in ACID is durability. When a transaction completes, the changes it makes are persisted. Delta Lake brings this same transactional support to Spark by implementing a transaction log and enforcing serializable isolation for concurrent operations. Delta Lake tables also provide us with data versioning and time travel. Because all transactions are logged in the transaction log, you can track multiple versions of each row and even use the time travel feature to retrieve a previous version of a row in a query. We'll see this coming up. Delta Lake tables support both batch and streaming data. While most relational databases include tables that store static data, Spark includes native support for streaming data through the Spark Structured Streaming API. Delta Lake tables can be used as both sinks, or also known as destinations, and sources for streaming data. We'll see this coming up too. The underlying data for Delta Lake tables is stored in the Parquet format, which is commonly used in data lake ingestion pipelines. It is a standard format for interoperability. To query your Delta Lake tables in Microsoft Fabric Lakehouse, use the SQL Analytics endpoint that is created automatically when your Lakehouse is created. Let's give you a little bit more background on Delta Lake tables. When you create a table in Microsoft Fabric Lakehouse, a Delta Lake table is defined in the metastore for the Lakehouse, and the data for the table is stored in the underlying Parquet files for the table. With most interactive tools in Microsoft Fabric environment, the details of mapping the table definition to the metastore to the underlying files are abstracted. However, when working with Apache Spark in the Lakehouse, you have greater control of the creation and management of the Delta Lake tables. Now let's see some examples. Let's focus on ways to create a Delta Lake table with code in Spark using a notebook. One way to do this is to save a data frame as a managed table in the Delta format. This is one of the easiest to create a Delta Lake table. Notice in the first part of our example, we're loading the mydata.csv file into the data frame from the Files folder, and we can see it has a header. After our CSV file has been loaded into the data frame, we next save the data frame DF as a Delta Lake table using the method called save as table to save my table, which will be stored in the tables folder as a managed table. In our next example, we are using Spark SQL to create our sales order table as a Delta Lake table. Using Spark SQL, the %% magic command with SQL and the create table statement. This looks just like a create table SQL statement with the schema defined here and the fields and data types listed. Notice that using the Delta statement at the end signifies that we are creating a Delta table. And lastly, we can also save a data frame in Delta using an explicit path. As shown here, the Delta path is using the Files folder to store the My Data table. The second line shows that we are writing from the data frame and creating the table using the Delta format and storing it in the Delta path defined above. This code shows how to save data in a Delta format without creating a table definition in the metastore. This can be helpful if you want to persist the results of the data transformations performed in Spark in a file format over which you can later overlay a table definition or process directly by using the Delta Lake API. Let's focus now a bit more on the differences between managed tables and external tables. In managed tables, the table definition is the metastore folder tables, along with the underlying data files, and both are managed by the Spark runtime for the Fabric Lakehouse. That's why deleting the table will also delete the underlying files from the table storage location in the Lakehouse. Now we've seen this syntax before. To save a data frame as a Delta Lake table using the save table as method and creating the table called my table as a Delta Lake table, but I want you to take a closer look at it and note there's no path. So right away that tells you we're going to be saving this table as a managed table off the tables folder with its table definition created in the metastore. You can see this clearly in the Lakehouse Explorer. You can also create tables as external tables, in which the relational table definition in the metastore is mapped to an alternative file storage location, which can be seen here in the path pointing to the Files folder storage. That location is in the Lakehouse, and it's where we're going to store our Delta table, my external table, using the save as table method. Now let's take a look at how you can work with Delta Lake tables using Spark. You can work with Delta Lake tables or Delta format files to retrieve and modify data in multiple ways. Here's an example of using the SQL embedded statement here in PySpark that is using Spark SQL. which is one of the most common ways to work with data in the Delta Lake tables. You can embed SQL statements in other languages like Scala by using spark.sql, the library. Here, we are inserting one record into the products table using SQL. Alternatively, you can use, again, of course, the %% magic command with SQL in a notebook to run your SQL statements too. Here we are using SQL to update the products table by setting the price to 2.49, where the product ID is equal to 1. However, it may be easier to use the Delta API when you want to work with Delta files rather than catalog tables. Here you can see that we are creating an instance of a Delta table from the Files folder that contains Delta files and is using the Delta API update method to modify the data in the Delta table. All the data we've explored up to this point has been static data in files. However, many data analytics scenarios involve streaming data that can be processed in near real time. For example, you might need to capture readings emitted by an Internet of Things or IoT device and store them in a table as they occur. Spark processes batch data and streaming data in the same way. Simply enable streaming data to be processed in real time using the same API. A typical stream processing solution involves constantly reading a stream of data from a source, optionally processing it to select specific fields, aggregating, grouping values, or otherwise manipulating the data, and writing the results to a sink, also known as a destination. Spark includes native support for streaming data through the Spark Structured Streaming API that is based on the boundless data frame in which streaming data is captured for processing. A Spark Structured Streaming data frame can read data from many kinds of streaming sources, including network ports, real-time message brokering services such as Azure Event Hubs or Kafka, and file system locations, to name a few. You can use a Delta table as a source or sink for Spark Structured Streaming. For example, you could capture a stream of real-time data from an Internet of Things device and write the stream directly to a Delta table as a sink. You can then query the table to see the latest streamed data, or you could read a Delta table as a streaming source, enabling near real-time reporting as new data is added to the table. In this example, a Delta table is created to store details of Internet sales orders. Here we see a hypothetical data stream of Internet orders is inserted into the orders_in table. To verify, you can read and display data using a data frame or DF from the input orders_in table as shown here. The data is then loaded into a streaming data frame from the orders_in Delta table. The Ignore Changes option is set to true, which tells Spark to ignore changes like updates and deletes in the Delta table. It will only read new data that is appended to the table. When using a Delta table as a streaming structure, only append operations can be included in the stream. Data modifications will cause an error unless you specify the Ignore Changes or Ignore Deletes option. Lastly, you can check that the stream is streaming by using the isStream property, which should return true. After reading the data from the Delta table into the streaming data frame, you can use the Spark Structured Streaming API to process it. For example, you could count the number of orders placed every minute and then send the aggregated results to a downstream process for near real-time visualization. Once the streaming data has been used as a source, it is written to a Delta table as shown in the code. Here we see the code is written to a streaming data frame to a Delta table. The output table path equals sets the path where the Delta table will be stored. The checkpoint path sets the path for the checkpoint location, which is used to write a checkpoint file that tracks the state of the streaming process. This file enables you to recover from failure at the point where the streaming process left off. Next, the Delta stream, which specifies that the data will be written in a Delta Lake format. Next, the print message streaming to orders_processed is to inform you or anyone running the code that the streaming process in the orders_processed table has started. It's useful for debugging or monitoring purposes to know the status of your streaming job. After the streaming process starts, you can query the Delta Lake table to see what is the output table. However, you might have a short delay before you can query the table. Here is the example of a possible query of the orders_process table and sorting it by order ID. When finished, stop the streaming data to avoid unnecessary processing cost using the stop method. Spark is a parallel processing framework with data stored on one or more worker nodes. In addition, Parquet files are immutable, which means they cannot be altered or modified. So new files are written for every update or delete. This process can result in Spark storing data in large number of small files, also known as the small file problem. It means that queries over large amounts of data can run slowly or even fail to complete. Optimized write is a feature of the Delta Lake, which reduces the number of files as they're written. So instead of writing many small files, it writes fewer larger files. This helps to prevent the small files problem and ensure that performance isn't degraded. In Microsoft Fabric, optimized write is enabled by default. It dynamically optimizes partitions while generating files with a default of 128 megabyte size. This helps to reduce the number of write transactions and make subsequent optimized operations faster, as they will operate on fewer files. Optimized write achieves the file size by using an extra data shuffle phase over partitions. This causes it to do a little bit of extra processing while writing the data. The small write penalty should be outweighed by the read efficiency on the tables. Optimized write is available on Delta Lake tables for both batch and streaming write patterns. Queries will scan fewer files with more optimal file settings, improving either read performance or resource usage. Use it when Delta Lake partition tables subject to write patterns that generate suboptimal or less than 128 megabytes or non-standard file sizes. Use it when repartitioned data frames will be written to a disk with a suboptimal file size. Use it when Delta Lake partition tables are targeted by small batch SQL commands like update, delete, merge, create table as select, insert into, etc. Use it when streaming ingestion scenarios with appended data patterns to Delta Lake partition tables and where extra write latency is tolerable. The optimize command in Microsoft Fabric is used to enhance the performance and efficiency of Delta Lake tables. Optimize is a table maintenance feature that consolidates small Parquet files into fewer large files. This is beneficial for big data processing engines and all Fabric engines, as larger file sizes, ideally closer to 1 gig, improve compression and data distribution across cluster nodes. This reduces the need to scan numerous small files, leading to more efficient read operations. By consolidating files and applying v-order, the optimize command helps achieve in-memory like data access times and reduces the resources required like network, disk, and CPU for read operations. Overall, the optimize command is a crucial tool for maintaining and improving the performance of Delta Lake tables in Microsoft Fabric. When you run optimize, you can optionally run v-order, which is designed for the Parquet file format in Fabric. v-order enables lightning-fast reads with in-memory-like data access times. It also improves cost efficiency as it reduces network, disk, and CPU resources during reads. vOrder is enabled by default in Microsoft Fabric, and it's applied as data is being written. It incurs a small overhead of about 15%, making writes a little slower. However, vOrder enables faster reads with Microsoft Fabric compute engines such as Power BI, SQL, Spark, and others. In Microsoft Fabric, the Power BI and SQL engines use Microsoft Vertiscan technology, which takes full advantage of vOrder optimization to speed up reads. Spark and other engines don't use Vertiscan technology, but still benefit from vOrder optimization, about 10% faster reads, sometimes up to 50%. vOrder works by applying special sorting, row group distribution, dictionary encoding, and compression on Parquet files. It's 100% compliant with the open source Parquet format, and all Parquet engines can read it. vOrder might not be beneficial for write-intensive scenarios, such as staging data sources where data is only read once or twice. In other situations, disabling vOrder might reduce the overall processing time for data ingestion. Apply vOrder to individual tables by using the table maintenance feature and by running the optimize command. The vacuum command enables you to remove old data files. Every time an update or delete is done, a new Parquet file is created and an entry is made in the transaction log. Old Parquet files are retained to enable time travel, which means that Parquet files accumulate over time. The vacuum command removes old Parquet data files, but not the transaction logs. When you run vacuum, you can time travel back earlier than the retention period. Data files that aren't currently referenced in the transaction log and that are older than the specified retention period are permanently deleted by running vacuum. Choose your retention period based on factors such as data retention requirements, data size, and storage cost, data change frequency, and also regulatory requirements. The default retention is 7 days or 168 hours, and the system prevents you from using a shorter retention period. You can run vacuum on an ad hoc basis or schedule using Fabric's notebooks. Run vacuum on individual tables by using the table maintenance feature. In Lakehouse Explorer, select the ... menu or the ellipsis menu next to a table and select Maintenance. Next, select the Run Vacuum command using the retention threshold, and then select Start Now. You can also run vacuum as a SQL command in a notebook. Vacuum commits to the Delta transaction log, so you can view previous runs using Describe History. Delta Lake allows you to organize data into partitions. This might improve performance by enabling data skipping, which boosts performance by skipping over irrelevant data objects based on the object's metadata. Consider a situation where large amounts of sales data are being stored. You could partition sales data by year. The partition could then be stored in subfolders named year equals 2021, year equals 2022, etc. And if you only want to report on sales data for 2024, then the partitions for other years can be skipped, which improves read performance. Use caution when partitioning small amounts of data, which can degrade performance. However, because it increases the number of files and can exacerbate the small files problem, be careful with using it. Use partitioning when you have a very large amount of data and when tables can be split into fewer large partitions. Do not use partitioning when data volumes are small or when partitioning columns has high cardinality, as this creates a large number of partitions or when the partitioning column would result in multiple levels. Partitions are a fixed data layout and do not adapt to different query patterns. When considering how to use partitioning, think about how data is used and its granularity. In this example, a data frame containing product data is partitioned by category. In the Lakehouse Explorer, you can see the data is partitioned with the table. There's only one folder for the table called partitioned_products. There are subfolders for each category. For example, category equals bike racks, etc. We can create this partition using PySpark to write a data frame to a Delta Lake table with partitioned by, or by using T-SQL's partition by. Use time travel to work with time versioning. Any changes made to a Delta Lake table are automatically logged in the transaction log for that table. View the history of the changes that have been made to the table and recorded in the log using the describe SQL command as shown here. You can also use time travel to retrieve older versions of the data. Notice that the describe history is available for both a managed table and an external table in the files folder. Here is a sample of the possible results you may see. Notice the informative attributes that can be viewed here. You can retrieve data from a specific version of the data by reading the Delta file location into a data frame, specifying the version required as a version as of option. Alternatively, you can specify a timestamp by using the timestamp as of option. Now it's time to use Delta tables in Apache Spark.
Welcome to how to use Delta tables in Apache Spark. We're going to do a little demo here that will get us started with how to work with the Delta tables here in Apache Spark. And how we're going to do it is we're going to open up a workspace. And I'm going to call this our DP700 Lab 3. And as you may remember from previous recordings, we're going to use Fabric, either the trial or capacity. And I'm going to go ahead and apply that. Then I'm also going to create a lakehouse. And so we'll take a look at some of the objects that are there throughout this course. But the lakehouse is the one that I want to focus on right now. I'm going to give it a name here. And I'm going to put LH so I can tell that it is a lake house. If I'm trying to find it in a list, that's always very helpful. I'm going to create that. That'll take just a moment here. And we will load it also with some of our lab files. So the lab file link is the one that you see right here. This is our products.csv available off of GitHub. And we would want to save that so that we can use it and upload it into our lab practice here. So you can simply right click it to save it, as you know. I'm going to go ahead and come back in here. And what I want to do is I'm going to upload it into files. So I'm going to create a subfolder there first. And I'm going to call the subfolder products. Then what I'm going to do is go ahead and upload the file. So here we have an option for that. And then I just have to find it. So I did save it onto my local system. And then here it is right here. And I will upload that. So that just takes a little bit of time there, as you can see. And now I have that products folder with the products CSV inside of it, as you can tell. So it's the same CSV type file we've been using for all of our labs here. Comma separated value files, easy enough to work with. But we are going to switch in to the notebook. And we're going to make a new notebook here. And we're going to look at that same data, but a little bit differently. So what we're going to do is we have that code cell here that, I'm very tempted to turn it into a markdown cell. So I'll go ahead and do that. And then what I'm going to do is I would like to load that product.csv into a data frame and be able to take a closer look at it. So what I'm going to do is I have some code here. I'm going to go ahead and copy in. And you can see it right there. So you can see the path right there where it's picking up that CSV file, and we're going to use it, loading it in. Actually, there's the syntax. I was pointing to the instructions, but right there you can see it, what we're loading in right there. It has a header on it, and what we'll see there is we're going to adjust it. So we're going to have a new structure added to it, product ID, product name, category, list price. You can see the data types that are there, and we've put it into a table. So you can kind of see the format there. So it's a data frame, but it's organized like a normal table would be organized, of course. So we have that. So that's one way of looking at it. So a couple different ways to look at that. Let me bring this up so that we can, and sometimes this takes a little bit there, but there it goes. And what we're going to do is we saw that CSV as a table. We've actually worked with the CSV numerous times, adjusting how we get it into a table format, putting it into loading it into a data frame, using the code. Remember, we used the CSV and we had it make a table. We had it loaded into Spark for us. We've done it a couple different ways. So there's a lot of ways to do it. This is just another way that we're showing you here how to view the data in that CSV file in a table format. A lot of ways to make that happen. But where we're going to go now is someplace a little bit different. We're going to work with what's called a managed table and then also an external table. And both of these are available for us to use here in our Lakehouse. So I'm going to open up the code here, and I'm going to put in the code right here. As you can see, what we're doing is we're going to create a managed table. So it is going to be a Delta table, and we're using save table as, or save as table, the method, to create this table called managed products. And notice we didn't really put a path on it. So this is going to be a managed table, which has a lot of benefits here in our Lakehouse. It actually runs better, so it has higher performance. And then Fabric will manage both the schema metadata and the data files. Now this took a little bit to run here, but it looks like we got it to work. I'm going to go into tables now, and I might have to refresh this. Let me see. So it's like, yeah, you can see it right there. So there's the managed products Delta table right there. Now what I can do is we could take a closer look at that a couple ways. Note, if I want to, I can see a little bit of and we'll see it right there. We can see some of the data, some of the fields and the data types associated with that. So we have managed products. So that's one of our tables. And then we also can create an external table. Now, to make the external table, we're usually talking about a table where we have the data stored externally, and just the metadata would be managed by Fabric. So I'm going to try some code here that will bring that to light. Notice it's the same syntax as before, the Delta table, save table as. We're going to call it external products, but then it's also, so it's going to be a Delta table in the tables folder, but it's also going to have its metadata pointing to external location. And so this location right here, we are going to use from files and copy our ABFS path there to add that in. And I'll go ahead and paste that in. And there you can see the path to that. So you can see the DP700 Lab 3, and then it's onelake.dfs.fabric.microsoft.com. And then it's the name of the Lakehouse. My Lakehouse was DP700 Lab 3 LH.Lakehouse, and it's going to put it off of files and external products. So we're going to see this actually in two locations. Our external table, remember, has data that is stored externally. So the metadata is the portion that is managed by Fabric. So we'll let this run for a moment. And we'll go ahead and refresh this too to see if we can see it. We should be able to see there's external products right there. And if we expand that, can we see, it might take it a moment, but you can see some of the fields involved with that. And then you can see too that under files, if we refresh that also, you'll see the option there where, let's see, there's external products right there. So it's stored in here. And you can see the information that's kept here with the Parquet and the Delta log. So a little bit of it there. So what we'll kind of highlight here is that the managed table manages both the data and the metadata. So that means that Spark is going to, and Fabric is going to help us here take care of the table structure and the partitions. And the data actually resides in a storage area here in Fabric that is managed by Fabric. So if I were to delete the managed table, both the data and the metadata would be deleted. The external table that you see there under Files, that is only, we're only really managing the metadata there, and the location is wherever the data is being stored, which could be, of course, externally if we need to do that outside of Fabric. We're going to see the locations coming up in a bit here. But if you were to delete the external table, only the metadata would be removed because the actual data is somewhere else in an external storage location. So kind of keep that in mind as we move through this, a little bit of the differences between the two. So what I'm going to do is I'm going to take this a step further, and this might help a little bit here, is I'm going to have a few, I'm going to turn on SQL Magic, the magic command there for SQL, and I want to find out more about that managed products table. And you can see, tells you a little bit about it, the fields that are there, the data types, and most importantly, I want to look at the storage location. So you can see where this is stored right here. So you have that path with our ABFSS for the Azure blob file system there. So it's using that driver. But what I want to highlight is we have one location. This is for the managed table. And then I want you to notice the location for the external table. So I'm going to run that code again, but this time ask it about my external products table and see what we get from there. And we'll again go look at the location, and you can see the location where it's stored. So there's the physical location, a little bit different than what you see here. So you can tell one is stored with tables, one is stored in files, and that might highlight a little bit more the difference between external and the managed table. Okay, so what I'm going to do is I'm going to get rid of both of these. And we won't use these again, so I'm going to go ahead and drop them. So we'll remove those. Now I want you to see what happens when I drop them. When I drop Manage Products and I refresh Tables to the point we made earlier, it's going to go away. So the Managed Tables are gone. That portion of it is gone. But when I dropped it also, I dropped the external products portion. The table went away, but the file down here, let's see if we still have that. Yeah, because it still has its metadata here. So you want to note that little bit of a difference here between external and managed table, how they react to deletions. And then let's continue on here and let's focus in on creating a delta table. We've created it a lot of different ways. There's yet another way that we can make it, and we're going to take a look at that right now. I'm going to put this code in, and you will see I can create a table a little bit differently, making it a delta table. I'm going to make a delta table by using our magic command here with SQL and having it create a table called products. And I'm just going to say using delta. So when we do that, we should note that it's going to be put into the same location here for files. And will we get the table up top? Let's see. We're going to refresh that. And yeah, so we have the metadata stored and pointing to a different location where the data is at, but the metadata down here and not the data itself. Okay, so this looks good. Another way to make a delta table, an external delta table there, that's a good option. I'm going to query it and see what it has inside of it. And if you're using this with me here, consider too, you can run some extra queries, query different things that you want to look at. So we'll just kind of add that in. There's what the products table currently looks like. Okay. Now keep this in mind with how the product table currently looks, because now what we're going to do is we're going to make changes to it. So we're going to run some updates. And again, we're going to use our magic SQL command, our magic command there using SQL. And we're going to have it update the products table and set the list price to list price times 0.9. And it's only going to be for where the category is equal to mountain bikes. So there's about 32 rows that were affected. So we might want to see exactly what that looks like. We're going to take a look at that in a moment here. But I want to see, since this is a delta table, remember, it can keep track of transactions. So I'm going to ask it to show me its history. And that will show me what has changed in the products table. Now you might remember we just created it, but then we also made an update to it. So there's version 0 and then there's version 1. Remember, we have ACID transactions here that are supported in Delta, so it can keep track of what we've done. And you can kind of see that from here. I also want you to be able to tell that we can call those different versions, the current one and then the previous one. And you can see one will show the current data, one will show the original data. I'm asking it to get me version 0 in that second command there. So there's what it used to look like. So this is what it currently looks like. And then version 0 is below what it used to look like. And you can see we had a 0.9% deduction that we took for mountain bikes. So you can see that you can call those versions if you need to too. So this is very handy. The ability to track transactions through that table gives us a lot of flexibility to do transactions. Now, what I want to do too is show you some of the other features that we have that you might find helpful. One of which is our ability to create a view. A lot of us like to work with views. Notice we have a view here called Products View, and it is querying the products table that we just created, and it's doing a count asterisk and putting that into the num products field. And then it's giving us the minimum list price, the maximum list price, and the average list price. And it's grouping it by category. So that gives us a good option there when we run that view. But that view, when we've created it, and then we're calling it right here, we're going to order it by category. So we're just adding to this statement here when we call the view here. So we're making it right there through step number 7, and then we are calling it down here, and you can see what it looks like. So the view can be very helpful to use here if you run queries that you want to do over and over again, make modifications to it. You can use the views to help out with that. What I'm going to do too is I'm going to try another query using that view as the source. Notice my source is from products view. And what I'm going to have it do is have it order by num products, the field, in descending order. So that's big number to little number. And then only show me the top 10. So you can see that. So there's a lot of SQL that you can use in here. I can even, if I needed to, get back to working with my charts. And that's pretty handy. But I could also remember come up here and I could go, since this is a lakehouse, I could switch into our SQL endpoint and use it to get directly into reporting. So a lot of ways to do it. We saw in our last lab section that you could also use matplotlib and you could use Seaborn. A lot of ways to show visualizations in here, which might be handy. Now, maybe you don't want to use the magic command with SQL. Maybe what you want to do is you want to just use PySpark. And you can use PySpark with some SQL functions. So there you can see it right there. So running the select command right in there to run our query. So a lot of ways to work with it. This should hopefully be somewhat straightforward, and you can repeat these and watch the video again and again and kind of play around with these on your own if you'd like. There's a lot you can kind of do here. We're just giving you some highlights. But what I also want to focus on is something that we're going to be talking about in the upcoming modules, and that is working with streaming data. So I'm going to go ahead and start off a little example that we have in this lab for that. Notice that we are importing some of our notebook utilities, that MS Spark utility in particular. And then notice too that we're pulling in some SQL types and SQL functions. So once we do that, we're making a folder. So there's going to be a folder out there that's going to be off of files called data. And that folder is going to hold the data that we are going to be using to kind of simulate Internet of Things. So this is working with streaming data. We're trying to simulate an Internet of Things scenario with this. So we have creating a stream that reads data from the folder, and they're kind of describing what's going to be in that file. It's going to have a device field or a table, a device field, and a status field. And we're going to stream data to it, and we're going to load some sample data right here that they're going to add to that file in that folder. And then you can see the path that it's using. So it's going to create a data.txt file. So I'm going to run this, and it's going to tell us if it's created at the end because it's going to give us a print statement right there. And so we should be able to find that data path here. So let me refresh this for a moment. And then there's the data, and there's that data.txt. Now I want to look at this very quickly, and I'm going to do it simply by going back to our workspace and then going into the Lakehouse for a moment here. And if we take a look now, this hasn't been refreshed, so we have to refresh it here. But there's the data, and there's that data.txt file right there. So you can see it loaded the device and then the status. So you can see a little bit of it there, which might be helpful. Okay, so back to our notebook here. And when we've set that up for us as a place to hold incoming data, and again, we're going to talk a lot about how to work with streaming data. There are a couple of modules we'll be focusing in on shortly. This is now writing the stream of data to that table. So it's going to make a table out of it. It's that IoT device data table it's going to create. And it will also have a checkpoint file. So in case we need to roll back to a certain point, we have a checkpoint to do that with. And what we'll do is we'll go ahead and run this. And then we'll check to see, well, that table should show up any moment here. Again, I'm going to have to refresh this just to make certain that we have it. There it is right there. So there's that table, that IoT device data table. And what we're going to do is we're going to check it out, but we're going to check it out right in here. So we'll go ahead and query it using our magic command there in SQL. If I can get this to run there, hit the wrong button. There we go. So you can see it right there. So it shows you what's currently in it. We're going to try to add more to that table and kind of simulate, data incoming here. So we'll add a little bit more to that. And let me run that also. And then what you'll see with this is we could run that one more time up here. Let's see what it looks like. And we should hopefully see some more records in there. Yeah, it looks like we have more records. Okay, so that's trying to simulate, streaming data somewhat here. And then what we're going to do is we're going to stop it right now because we're going to pick this up a little bit later in our conversation. And we're going to focus in on finding out a little bit more about streaming data. So this is just a teaser, and more to come definitely on this. Okay, so I'm going to go ahead and run this cell to stop it. And I want to thank you for joining in today, and hopefully we will see you for the next session.
In this section, we covered how to work with Delta Lake tables in Microsoft Fabric. We started off answering the question what is a Delta Lake and Delta Lake table in Microsoft Fabric. We then talked about how to create and manage Delta Lake tables using Spark. We also focused on how to use Delta tables with Spark structured streaming. Then we went into how to optimize those Delta tables with optimize command, vorder, vacuum command, and more. Lastly, we focused on partitioning files, data versioning, and time travel. For more information on how to work with Delta Lake tables in Microsoft Fabric, please see the link here. This concludes session 4. We will take a quick 10-minute break before starting with session 5, Ingest Data with Dataflow Gen 2 in Microsoft Fabric. Welcome back from the break. In this session, we will describe Dataflow Gen 2 capabilities in Microsoft Fabric. We will discuss how to create Dataflow solutions to ingest and transform data, and we'll focus on how to include a data flow in a pipeline. Let's get started in session 5. There are two primary high-level features Data Factory implements: data flows and pipelines. Dataflow Gen 2 enables you to leverage a low-code Power Query online interface and 300-plus data and AI-based transformations, letting you transform data easier and with more flexibility than any other tool. Data pipelines enable you to leverage rich out-of-the-box data orchestration capabilities to compose flexible data workflows that meet your enterprise needs. You might be asking, what is a data flow? Data flows are a type of cloud-based ETL, or extraction, transformation, and loading tool for building and executing scalable data transformation processes. Dataflow Gen 2 allows you to extract data from various sources, transform it using a wide range of transformation operations, and load it into a destination. Using Power Query Online also allows for a visual interface to perform these tasks. The ability to specify an output destination along with an enhanced compute time are what set Dataflow Gen 2 apart from its predecessor. Data flows allow you to promote reusable ETL logic that prevents the need to create more connections to your data source. Data flows offer a wide variety of transformations and can be run manually, on a refresh schedule, or as part of a data pipeline orchestration. Dataflow Gen 2 is only available in Fabric and not in Power BI without a Fabric license or trial. Traditionally, data engineers spend significant time extracting, transforming, and loading data into a consumable format for downstream analytics. The goal of Dataflow Gen 2 is to provide an easy, reusable way to perform ETL tasks using Power Query Online. Data flows allow you to promote reusable ETL logic that prevents the need to create more connections to the data source. Do consider that there is more than one way to ETL or ELT data in Microsoft Fabric, as we will discuss coming up. Now let's take a look at the benefits and limitations of using Dataflow Gen 2. Some benefits noted here are that it allows self-service users access to a subset of the data warehouse separately. You can also optimize performance with data flows, which enable extracting data once for reuse, reducing data refresh time for slower resources. Consider simplifying data source complexity by exposing data flows to larger analyst groups and ensure consistency and quality of data by enabling users to clean and transform data before loading it into a destination. Some limitations to be aware of are that data flows aren't a replacement for a data warehouse. Creating a data warehouse is still your best option to use for organizational reporting needs. Also note that the Fabric Capacity Workspace is required to create Dataflow Gen 2 and that row-level security isn't supported. So consider using other security options to supplement here. Look for more on security in later sections. Now let's explore Dataflow Gen 2. Please note, number 1, Power Query Ribbon. Dataflow Gen 2 supports a wide variety of data source connectors. Common sources include cloud and on-premise relational databases like SQL, Excel, or flat files, SharePoint, Salesforce, Spark, Fabric Lakehouses, and more. Then there's numerous data transformations possible. As I mentioned earlier, it's over 300 plus ways to do transformations in our Power Query Online. You can do transformations like filter and sort rows, pivot and unpivot, merge and append queries, split and conditional split, replace values and remove duplications. You can also have it add, rename, reorder, or delete columns. It can do ranking and percentage. You can have it choose the top N where you define N, or the bottom N where you define the number that goes there too, and many, many more. You can also create and manage data source connections, manage parameters, and configure the default data destination in this ribbon. Notice number 2, the queries pane. This shows you the different data sources, now called queries on the left here. These queries are called tables when loaded into the data store. You can duplicate or reference a query if you need multiple copies of the same data, such as creating a star schema and splitting data into separate, smaller tables. You can also disable the load of the query in case you need to do a one-time import. Number 3 shows the diagram view, which allows you to visually see the data source. The data sources are connected along with the different applied transformations. For example, your data flow connects to the data source, duplicates the query, removes columns from the source query, then it unpivots the duplicate query. Each query is represented as a shape with all of the applied transformations and connected by a line for the duplicate query. You can turn this view on or off. Number 4 is the data preview pane. This only shows a subset of data to allow you to see which transformations you should make and how they affect the data. You can also interact with the preview pane by dragging and dropping columns to change the order, or right-clicking the columns to filter or make changes. The data preview shows you all the transformations for the selected query. Number 5 highlights the query settings pane on the right, which includes the applied steps. Each transformation you do is tied to a step, some of which are automatically applied when you connect the data source. Depending on the complexity of the transformation, you might have several applied steps for each query. Most steps have a gear icon that allows you to modify the step. Otherwise, you must delete and repeat the transformation. Each step also has a contextual menu when you right-click, so you can rename, reorder, and delete the steps. There's no undo button in this section, so to undo an unwanted step, simply click the gray X next to the step. While this visual interface is helpful, you may also view the M code through the advanced editor. In the query settings pane, you can see the data destination option there at the bottom, and that will give you the ability to see where your data is going to land. And it can have a destination like a lakehouse, a warehouse, or a SQL database, as you can see. You can also load your data flow to Azure SQL database, the Azure Data Explorer, or even Azure Synapse Analytics. Lastly, Power BI developers should be familiar with this interface, as it is similar to the Power Query editor in the Power BI desktop, and you should be able to quickly pick it up and perform the transformations upstream here very easily and improve performance for your reports. Dataflow Gen 2 provides an excellent option for data transformations in Microsoft Fabric. The combination of data flows and pipelines is useful when you need to perform additional operations on the transformed data. Data pipelines are a common concept in data engineering and offer really a wide variety of activities to orchestrate. Some common activities include copy data, incorporate data flow, add notebook, get metadata, and execute a script or a stored procedure. Pipelines provide a visual way to complete activities in a specific order. Remember that you can use a data flow for data ingestion, transformation, and landing into a Fabric data store. Then incorporate that data flow into a pipeline to orchestrate extra activities, like executing scripts or stored procedures after the data flow has completed. Pipelines can be scheduled or activated by a trigger, or you can run a data flow manually. By using a pipeline to run your data flow, you can have the data refreshed when you need it instead of having to manually run the data flow. Consider automation as much as possible to allow you to focus on other responsibilities. Now let's create and use Dataflow Gen 2 in Microsoft Fabric.
Welcome to lab number 4, create and use Dataflow Gen 2 in Microsoft Fabric. Let's begin. So we need to start, of course, with getting out to Fabric at app.fabric.microsoft.com. Then we need to create a workspace, or you can use a workspace that you're currently using if you'd like. I'm going to keep mine a little bit separate here. And you can call the workspace anything you like to call it. I'm going to use the DP700 Lab 4 is my workspace name. And then most importantly, we need to make certain that we are using Fabric license mode, either Fabric Capacity or the trial. I'm going to go ahead and apply that. And that will create my workspace for me very fast, as you can see. And then what I want to do is create a lakehouse. So I'm going to go in and add our lakehouse option here. And the lakehouse is here under store data. And I'm going to call it DP700 Lab 4 Lakehouse. And let me capitalize that just so everything is similar. And I'm going to hit create. So now I have my lakehouse, I have my workspace, and I'm ready now to ingest data. And what you'll note with this is you can handily get it right here under Get Data. I can choose from a lot of options. We spend a lot of time uploading files to our lakehouse, but you can also, as you know, use sample data. You can shortcut it in. We will eventually talk about pipelines in this section a little bit towards the end, but right now we're going to focus on the Dataflow Gen 2. So I can grab it from here. I can also grab it from over here. Just going to pick it up from right here. That'll take me into my Dataflow Gen 2, which is also known as the Power Query Online Editor. And in this editor, it is really, really easy for us to use it, especially if you've used it with Power BI on-prem. So what I'm going to do is I'm going to import a file. And where I'm going to grab this from, I'll give you the link right here. This is the path. It's an orders.csv file off of GitHub. You can see what it currently looks like inside. So what's involved with it there. You can see the CSV input there, the data there. And what I'm going to do is I'm going to copy this and I'm going to use that as my path. So I'm going to have it linked to a file. I already created a connection earlier, but if I needed to, I could create a new connection right here, adding in the gateway if I need one, the authentication, and the privacy level. But since I already have a connection, I can use it from right here. And then I'm going to click on Next. And it should get connected to it here. Might just take a moment to do that. And it's going to show you the file. So this should be equivalent to what we saw back here. It's just organized a little bit differently here into a table type format. And then what I'm going to do with this is I'm going to go ahead and click Create to use this as our data source. So then it pops me into Power Query. And the Power Query here, just so we're clear about this, Power Query actually has about 300 plus transformations that it can do. So we're not going to really touch all of them in this course, but you definitely want to check some of the ones out there that you could use in your scenarios. What I'm going to do right now, though, is I'm going to go in and get into custom column. I'm going to add a custom column in a moment, but you can see that it lists out here the source was a CSV. It had promoted headers. So there's a header in that list there. You can kind of see that first line is the header. And then we also have the column type was adjusted here for the data type. So what I'm going to do is I'll go ahead and add a column, and I'll do a custom column here. And I'm going to call this custom column that I'm going to add to this, I'm going to call it month, but not all in uppercase here, month number. Then what I'm going to do is I'm going to change the data type to whole number. And then I need to let you know the formula is actually case sensitive. So if you type a lowercase d in date rather than an uppercase, you may not get the result that you want. So I'm going to do date dot month, and then I'm going to do open parenthesis, and I'm going to go find order date here and insert it in. So, and then I'm going to go ahead and click OK to that and see if we can get the result that we're looking for there in that extra field we've just added there, custom column month number there. So we can see that there. So it looks good. It looks really good for us to have that. Now what we're going to do is we are going to go and check our data type. So the order date has a date data type, and you can see some of the data types through here. This one, of course, has, we set it to whole number. So we have those data types looking good there. Then what we're going to do is we would like to ultimately have the destination of where we're pulling in from the source. We have the promoted headers. We have the column change there for the data type, and then we added that custom column. We would like this to actually go out to our lakehouse. So there's a couple places we can do this from. This is the one that I prefer right here of just choosing the different locations. I could push it out to the lakehouse, a workspace. You have other methods you can add in here. But we could also come up here, and through here you can see kind of the destination also listed there. So what I'm going to do is I'm going to delete that lakehouse there, and I'm going to go ahead and connect to the destination a different way. I'm going to click on the plus here. I'm going to choose the lakehouse, and it's going to have to get connected to the lakehouse. So you may have to edit the connection to do this, but it has to connect me to it. And I already have lakehouse listed there. So I'm going to see if I can just hit next and see if it will connect out to the lakehouse. Now there's the table that we want to put at that destination. And I'd like to put it actually at the DP700 Lab 4 and into this lakehouse right there. So that was the lakehouse I created just at the beginning of this lab. So I'm going to choose that as my destination. That's my target right there, putting it into that lakehouse. And it's going to show you what the source looks like, what the destination looks like. The data types are going to matter here, so we want to make certain the data types match up. But we also want to make certain that we can not only have the table created, orders on that lakehouse, but we also want to be able to add to it as we go. So we don't want to do necessarily replace. We want to do a append. So I want to just append whatever's there so I can keep running this over and over. So I'm going to go ahead and save those settings. And then what we'll notice is that we will want to then publish this out. So I'm going to go ahead and publish this. And that should set this up for us. So the data flow is being created right now. And what you can do with the data flow, as you know, is you could add a data flow to a pipeline. So that's really what I want to do. I want to add a data flow to a pipeline. So I'm going to go up to the new item here, and I'm going to find the pipeline, and we'll open that up. And we can call that, pipeline 1 is fine enough, good enough, or we could maybe change that out maybe a little bit. Maybe we do DP700 pipeline. We could call it pipeline or pipeline 1, how we'd like to do that. Notice the data flow took a little bit to create, but it is created here. So I'm going to hit create for that for the pipeline. That'll move me into the pipeline itself, where I can then do some configuration. So what I want to do is I want to go ahead and set this up a little bit. So I'm going to add a pipeline activity here, and I'm going to select data flow. So when I add data flow, it'll add it to my list here. And then what I'm going to do is I'm going to have to configure this. I'm going to go into settings, and it is actually from our workspace that we just created. And the data flow in there is our data flow 1. So that's the one I want to add to this. Now I'm going to go ahead and also save this with that little save button right there. Then what I'm going to do is I'm going to run this and see if we can get this to work. So what it's going to do is I want it to run the data flow, which will connect to that data source out in GitHub. And then what it will do is it will take that order table, the information inside that order CSV file, and it will do a couple changes to it, as you saw, get connected to the source. It'll add that custom column. It will adjust that one data type that it needs to adjust, and then populate an orders table in our Lakehouse. So that's what we're trying to do with this, get it to have that orders table added to the Lakehouse and then populate it with the data. So it's going to take it a minute to run here, so we'll just let it run for a couple seconds to let it run. And then we're going to go check out the Lakehouse and see if we have the orders table populated with the orders data from GitHub. So this is an easy example to show you how to do some ingestion involving both the pipeline and also the data flow. And as I mentioned earlier, if you've worked with Power BI Desktop on-prem, and you've worked with the Power Query editor to do your transformations, you can do those same transformations in Fabric through Dataflow Gen 2. So that should be helpful. So we'll just wait for this to continue to process, and then we will hopefully see it succeeded. Okay, so that was pretty slick. I'm going to go now to our, let's go back to our workspace, and I'm going to find that Lakehouse. And then I'm going to go into tables and refresh right there and see if we can find it. We should be able to find it there. There it is. There's orders. And now, does it have the records from GitHub? And it should. Let's take a look. So it's taking a moment to do a little preview. There's a lot of records out there. And we should hopefully see, yes, looks like we have the records. Okay, so it looks good. And again, it's only showing about 1,000 rows, and we can have it show more, but that's the default here. So this looks good. I hope you liked this. I hope it helped also with understanding a little bit about data flow and then also the pipeline, but more on each of those topics coming up. Thank you so much.
In this section, we talked about Dataflow Gen 2's capabilities in Microsoft Fabric, looking at its benefits and its limitations. We also discussed Dataflow Gen 2's solution to ingest and transform data, many which are low to no code in a graphical environment designed for ETL. We also explored Dataflow Gen 2's multiple panes in its interface. And lastly, we talked about integrating Dataflow Gen 2 into a pipeline. More on that topic coming up. This concludes session 5. We will take a quick 10-minute break before starting with session 6. Use Data Factory pipelines in Microsoft Fabric. Welcome back from the break. In this session, we will describe pipeline capabilities in Microsoft Fabric. We'll also focus in on how to use the copy data activity in a pipeline, along with how to create pipelines based on predefined templates. Lastly, we will run and monitor our pipelines. Let's get started with session 6. There are two primary high-level features Data Factory implements: data flows and pipelines. Data pipelines enable you to leverage rich out-of-the-box data orchestration capabilities to compose flexible data flows that meet your enterprise needs. Data Flow Gen 2 enables you to leverage a low-code interface and 300-plus data and AI-based transformations, letting you transform data easier with more flexibility than any other tool. Pipelines in Microsoft Fabric encapsulate a sequence of activities that perform data movement and processing tasks. You can use a pipeline to define data transfer and transformation activities, and also to orchestrate these activities through control flow activities that manage branching, looping, and other typical processing logic. The graphic pipeline canvas in Fabric user interface enables you to build complex pipelines with minimal or no coding required. Activities are the executable tasks in a pipeline. You can define a flow of activities by connecting them to a sequence. The outcome of a particular activity, success, failure, or completion, can be used to direct the flow of the next activity in the sequence. There are two broad categories of activities in a pipeline. Number one, data transformation activities. These activities encapsulate data transfer operations, including simple copy data shown here that extracts data from a source and loads it into a destination, and can provide more complex data flow activities that encapsulate data flows and can apply transformations to the data as it is transferred. And two, control flow activities to implement loops, conditional branching, or manage variable and parameter values. Using the Copy Data Wizard, you can choose and then connect to your data source, and then you can also choose and connect to your data destination to create the copy data activity. You can also edit its settings here below the pipeline canvas for more specific detail. There are many common pipeline scenarios in which Microsoft Fabric includes predefined pipeline templates that can be used and customized as required, as shown here. From bulk copy from a database to even copying multiple files between file stores, we have starter templates to get you started. To create a pipeline based on a template, select the Choose a Task to Start tile in a new pipeline and follow the prompts. When you have completed a pipeline, you can use the Validate option to check that its configuration is valid, and then either run it interactively or specify a schedule. The Run button will manually trigger a data pipeline run. When you schedule a data pipeline run, you can choose the frequency that the pipe runs. You can select Schedule found in the top banner on the Home tab to view your options to see what's there. However, remember that by default, your data pipeline won't be set on a schedule. When you view a pipeline run history from the Workspace page, you can select the Run Start value to see the details of your individual run, including the option to view the individual execution time for each activity as a Gantt chart. Now let's see how to ingest data with the pipeline.
Now let's move into another lab here, another demo that we'd like to do, which is our ingest data with a pipeline in Microsoft Fabric. So this demo is going to have you create first a workspace. Just like every other demo, we start off with making certain that we have a Fabric workspace. And I will call this DP700 Lab 5. And then I'm going to make certain that it's set up with a Fabric trial license or a capacity license. And I'm going to go ahead and apply it. So this will take just a moment. And there you have it. We have our workspace. And in this workspace, what we're going to do is create our lakehouse. So the lakehouse, we're going to find in here under Store Data, and we'll go ahead and do a DP700 Lab 5 lakehouse. And that'll take just a moment to create. And then what we're going to do to populate this lakehouse is we are going to go ahead and create a pipeline. So before we do that, I'm going to create a folder here off of Files that will hold our information. I'm going to go ahead and click Create there. Then we're going to click on New Data Pipeline. You can see our SQL Analytics endpoint has been created here. And this pipeline we are going to call Ingest Sales Data. So this will be our new pipeline here to get connected to our data source. And that will take just a moment to get into that new pipeline. Now, to create the new pipeline, we are going to be using the copy data activity here. As you can see, it's like a little wizard we can fill in information for. And what we're going to do is we are going to use a source from GitHub. So I'm going to go ahead and tell it we want to use an HTTP source. And I just typed it in the top and it did a little search for me. Then what I'm going to do is have it use a sales.csv file from GitHub. So I'm going to go into the URL and I'm going to paste it in here. Now, if you want to see what this is, I actually have it listed in here too, so you can get a better look at it right there. So it's from GitHub, and you can see it's our CSV sales file there. Then what I'm going to do is I already have a connection to it, but if I needed to make a connection, I could choose Create New Connection and fill out the information there for the gateway and then the authentication kind. But what I'm going to do is use the connection that I have to get to it already. I'm going to click on Next. And I'm going to fill out a little bit of information here about our source. So the request method is definitely going to be a GET. And we will see too that the rest of this, we're just going to leave it blank. So using the GET method there, I'm going to click Next. And then it's asking me a little bit about our source. And we do know that it is a delimited text file. However, there's other options you can select there as your source if you'd like. But in our example, the delimited text works for us. It's a comma delimited for our columns. And then for the rows, it's actually separated by a line feed. And there's other options there I can choose too. So as you work through this and add in a little bit about our source connection here, what I'm going to do is I'm going to go ahead and click on Preview and see if we can see the data right now. So the data looks pretty good. So I want to go with this. I'm going to go ahead and click on Next. And now it wants to know the destination. So the destination that I'd like to put this is in the Lakehouse. And since it's a CSV file, I'm going to put it under Files. So I'm going to choose that option there. And then for my folder path, I want this to write out to the path called New Data, new_data. And I can see that right there. Then for the file name, I'm going to enter in what I like to call it, which is our sales CSV file, and I could type that in. And then for the copy behavior, I'm not going to put anything at this point, but there's other options you could select as you note here. So I have the folder path to go to new data. That was that folder that I made off of files. And then I have a new file that I want it to create called sales.csv. And again, it's going to be a CSV file, so we want to use delimited. We want to use the comma. we want to change the row delimiter to a line feed. And then we're going to have it add the header to the file. And then no compression on this. So I'm going to click on Next here. And you're going to see a little bit there, a little recap of what it's doing. So taking that CSV file from GitHub and pulling it in to our Lakehouse to a CSV file off of Files and New Data. So I'll go ahead and run this, and it will take just a moment to get us into our other window here where we can have it available. So it's creating it right now. We're just letting it run its course right here. And it's showing you if it can do it right now. So it's going to run it. So it created it. It's running it right now. And then we can go check it too to see whether or not we got it pushed to where we want it to go. So it'll take just a moment. And then we can go check out our Lakehouse and see if we see it added. Okay, so that happened in about 21 seconds. Not too bad. So I'm going to go over to the Lakehouse, and I think I have it right here. And when I click on the Lakehouse, there's new data. And if I click on new data, there we have it, sales.csv. And if I click on it, you can see the data inside. So we were able to ingest the sales CSV file from GitHub into our Lakehouse. Okay, so that looks pretty good. Now what we're going to do is kind of also associate a notebook to our pipeline. So let's do that from here. I'm going to go ahead and create a new notebook. That'll take a moment, as you know. And you'll see that we have our code cell initially added to this. There's our Lakehouse. We can expand on that a little bit. Let's see if I can get the two options there. And then what I'm going to do is I'm going to create a new code cell here. And I'm going to hover to get that little code button there. I'm going to paste it in. And then what I'm going to do is I'm going to turn this into a parameter. So watch what happens when I toggle parameter cell. I want to use this as a parameter, see how it shows up as parameters there. And if I click it again, you can see it will toggle it off. So I'm just going to add it as a parameter cell right there. And then what I'm going to do is I'm going to add in some additional code. Now, we did talk about code in a previous section, so you may remember that. And we're going to use some of that same code right here. So we're going to have it go ahead and import some of our PySpark SQL functions. One of the functions that we're going to use here is to do some transformations. So first off, we're going to have that information from the CSV file put into a data frame. So we're going to read that into read the new sales data there from that CSV file. Then what we're going to do is we're going to manipulate the order date field and extract from it the month and also the order date itself. I'm sorry, the year and the month from the order date field. So we're picking up the year and the month from the order date field there. And then we're going to go to that customer name field and we're going to split it so that we can extract our last name and first name. And you can kind of see those right here. And then we're going to reorder the columns and use these columns here. And you can see the order we have them in. And then we're going to load this from the data frame into a table. So we're going to make a delta table there at the end, picking up the table name that was mentioned up here in our parameter. So you can see the table name is going to be picked up right there. And so it's going to be called sales. So what I'm going to do is I'm going to run all of these rather than just each cell individually. And then what we'll hopefully see at the end of this is a table called sales that is available. Now recall that this is the first time I'm using it here in this session. So it takes it a moment for the session to start, and then it's going to run our process. And then once it's started, of course, everything runs fairly fast after that. So we're waiting for the green light that things worked well. And then what we'll do is we'll take a closer look at our Lakehouse. Okay. So you can see that it succeeded. So I'm going to go back into the Lakehouse here and I'm going to take a look to see if we have that table. So I'm going to try just clicking it. I might have to refresh it. Let me do that. Let me do a little refresh there. And there you have it right there. So there is the sales table. And if I expand it, you can see the fields that it has listed in it. And it should be the same order as what we have right here. Same names and same order. If I want to see what's inside of it, one of the things I can do is I'll go back into the Lakehouse for a moment through this view. And I'll refresh tables here so we can see it even through here and get a little sneak peek of what sales has inside of it. So as we look a little closer, it takes a moment for the preview to show up, but we should hopefully be able to see the result. Okay, so that looks pretty good. There's our table right now. So that looks really good. What I'm going to do though is I'm going to go back to the notebook for a moment, and I'm going to go ahead and give it a name. So I'm going to click on our settings icon here, and let me give it a name that we're going to be using in the future here called Load Sales. And we should see that reflected in here. Well, we'll be able to pick it up from our list. So let me just check that it went in, and I think it did there. So it is called Load Sales. Okay, so we have that. So this is good. Now what we're going to do is we are going to go and move back into the pipeline and do a few more things in there. So I'm going to go back into our ingest sales data pipeline here. And in the pipeline, what I'm going to do is I'm going to add another activity to our list here. Now the activity I'm going to add from this, I could pick really anything from off this bar at the top here, but you have some additional activities kind of hiding out over here on the ellipses. I'm going to choose delete data, and I'm going to make it be our first step. So I'm going to pull up, you can do on success, on failure, or on completion. So as soon as the delete data step finishes, then I want it to copy the data. So I'm going to alter this a little bit here. I'm going to go into our delete data here. I'm going to change the name, and I'm going to call this delete old files, because that's exactly what I want it to do when this runs. Delete the old files that were there. And then I'm going to go ahead and adjust the source. So the source is going to be my Lakehouse, and I'm going to use a wildcard file path here, and it's going to be under the folder path here of files / and you may remember we have that subfolder new _ data. So I will add that in, and then the wildcard file name I want it to work with is really anything that ends in CSV in that path. And I can note too here, there's logging settings, and you're noticing that there's little ones up at the top where it's kind of telling you that, hey, there's some changes you need to make here. And I'm going to disable the logging part of this. So that should set me up here to ensure that really any existing CSV files are deleted before copying my new CSV file in step number 2 right here. So we have that as part of our activities here that we've added to our pipeline. What I'm going to do next, however, is add in a notebook. So you can add a notebook to a pipeline, and I'm going to go ahead and pull it over here. And I also would like it to run on completion, but we're going to delete the old CSV file before we copy the new data from our source, which was off of GitHub. And then once that runs, then we're going to have it do the notebook options, or the notebook that we used earlier. We're going to have it run those statements. So what I'm going to have to do is configure the notebook to make that happen. So I'm going to, at this notebook, kind of give it a little bit of a different name, because the code that we were using in the notebook is really to load sales. So this is going to be called Load Sales Notebook. So let me add that in here. Then I'm going to click on Settings, And I'm going to make certain that it's picking up from my workspace, which was DP700 Lab 5. And then I also want to make certain that it's using that notebook called Load Sales. And I'm going to have to add in the parameter. So this is similar to what we wrote out earlier, where we're going to create a new parameter here. And the new parameter is called table underscore name. It is going to be a string data type, and the value is new underscore sales. So we'll set that up here. That will take that table parameter and pass it to the notebook, and then override any default value that was assigned with the table name variable in that parameter cell. So we want to go with that. And then what we're going to do is we're going to save this. I'm going to go back to home and save this for a moment. And I'm going to give this a try. Let's run this and see what happens. So we'll run our pipeline here. So it's going to begin, and maybe I didn't click it quite right. It's going to begin with first deleting old files, deleting data. And then once that succeeds, notice it's been queued. It will take a couple seconds to run that. And then once that runs and it succeeds, then it will go on to the next step. So we'll just give it a moment to complete. And notice it has succeeded. Now our copy data step is run. So getting connected to GitHub and pulling in that sales CSV. So we've deleted the old file. We're pulling in a new one. And now after that, once that succeeds, we're going to have it run the script in our notebook. So we'll just give it a little bit of time, and that one has succeeded. So they both took just a little bit of time to run, both the delete old and the copy data. Both those steps were very, very quick. The notebook might take a little bit longer. We'll see what happens. Now you can run this pipeline on demand like we're doing right here. You could also run it on a schedule. So there's a timer that you can work with if you'd like. And then of course you can go in and you can add a trigger. Maybe I want the pipeline to run in response to an action. So there's a lot of ways to get it to run. And then you can also go in and view the history on it and see if it ever ran. So we're going to give it a moment here. Now, sometimes there's a little bit of an issue with its connection, the notebook's connection to the Lakehouse. And that might be what's going on here. So we'll give it just a little bit of time, but I think that may be going on here. Because this usually runs in under a minute. So what I'm going to do is I'm going to cancel it right now. And what I'm going to do is I'm going to go out to the notebook itself, which is this one right here. And in the notebook, what I'm going to do is I'm going to remove the Lakehouse. And this may happen where you have to just reestablish the connection to it. And then I'm going to go ahead and add it back. So it's one of our existing data sources. There's the Lakehouse. Let me just add it back. And then I'm going to go back to our pipeline again. And I am going to run it one more time. So let's give this a shot now. So yeah, there's like a certain time this should run in. We've run it a couple times, so we kind of have an idea. And if it takes a lot longer, then there could be an issue. And one of the issues is what I had said, that sometimes the notebook and the Lakehouse are not communicating properly. So removing the Lakehouse and adding it back will usually fix it. So notice both of these ran a little faster than before, but in particular, the delete old files ran very fast. So that's a good option. And then the notebook is hopefully going to run in under a minute. So I'm hoping it'll be very soon when we will see this. There it goes. Okay, perfect. So that was a good fix. It ran fairly fast, honestly. So what I'm going to do is we're going to go verify this information now. And what I'm going to do is I'm going to go over to our tables, and this is under our Lakehouse there. And I'm going to take a look at tables, and I'm going to refresh this, and we should see we have our new data loaded here. And we can see the little preview there. So, okay, so this looks good. Thank you for joining me in this session, and I look forward to seeing you in our next session.
In this section, we covered how pipelines can be used to orchestrate processes through activities, parameters, and pipeline runs. We also discussed data movement, which can be done through the copy data tool, and we looked at some common activities. We mentioned the starter templates too that can be used for an easy, quick start into copying data. Lastly, we focused on the options for running and monitoring our pipelines. This concludes our course on Microsoft Azure Virtual Training Day, Implement a Lakehouse with Microsoft Fabric. Let's recap what we covered. We first talked about end-to-end analytics using Microsoft Fabric. We also talked about working with lakehouses in Microsoft Fabric. And then we explored using Apache Spark in Microsoft Fabric, and then how to work with Delta Lake tables, also in Microsoft Fabric. And then one of the pivotal areas was ingesting data with Dataflow Gen 2 in Microsoft Fabric. And then lastly, we focused on how to orchestrate our processes and move data with Microsoft Fabric using pipelines. Thank you for attending the Microsoft Azure Virtual Training Day, Implement a Lakehouse with Microsoft Fabric. Remember that there are many ways to continue your learning journey. Check out Microsoft Learn at aka.ms/learn for a variety of self-paced learning options. Happy studying.